Okay, good afternoon, everybody, and welcome to webinar 4, our last webinar this year of the series we've been conducting on ensuring accurate classification of BRCA1, BRCA2, and other HRR gene variants. We've got a great webinar for you today, scheduled to take about 90 minutes. Excuse me. So we should have plenty of good and hopefully insightful discussion for you as well at the end in the Q&A session. So next slide, please. So the usual standard housekeeping, we have muted everybody's microphones, so please do avoid using your microphones. We are recording this webinar, so you will be able to watch it back afterwards at some stage. We normally takes us a couple of weeks to turn it around, and we will, of course, notify all the participants via our GenQA and EMQN YouTube channels that's where the webinar will be available. And most importantly, as always, this is a session for you. It's supposed to be an educational session. Please do ensure that you try to contribute to the discussion. We have a Q&A session at the end. Myself and Sandi Deans, my co-chair, will be hosting that. Use the Q&A function on Zoom to submit your questions to us. We've got about 30 minutes dedicated for it. We'll try and make sure we get through all the questions if possible. But if we don't, then please be rest assured that we do keep a record of all the questions, and we will be addressing any questions we haven't got around to it in the scheme report after the webinar is closed, when we publish the actual scheme report itself. Next slide, please. We also want to learn from it as well, so your feedback is important to us. It helps us make sure we deliver good quality, high quality webinars for you. So after the webinar, you'll receive an email with a link to a short feedback survey. Doesn't take more than a couple of minutes to complete. Please do give your time to contribute to that survey, and we really look forward to receiving your feedback on the webinar. Okay, next slide, please. Right, so without further ado, I'm going to kick off the opening, and just to say we have 3 fantastic speakers today who've contributed a significant amount of work into making this webinar available to you. We have Professor Kathleen Claes from Ghent in Belgium, Miranda Durkie from Sheffield in the UK, and Professor Thomas van Overeem Hansen from Copenhagen in Denmark. We'll be dividing up the various variants with it, each of them giving their time to 2 variants, I think, if I remember rightly. We are chairing, myself and my colleague, Professor Sandi Deans from GenQA, are chairing the webinar, and we'll be chairing the Q&A afterwards as well. Next slide, please. So this is our disclaimer, and I'll hand over to Sandi for the introduction.
Thank you, Simon, and a big welcome from me as well. So we are delighted to now give you an overview of the participation and some of the results from the Run 13 for our BRCA1, BRCA2 and other HRR gene variant classification assessment. So this EQA was run over the month of October, and we now have the collated results to share with you today. So next slide, please. So this assessment is run on the online platform, which is provided through GenQA, the Genie platform. So this is for individual education. There's multiple different resources there for nomenclature and other variant classifications, including SNVs, CNVs, prenatal, postnatal, etc. So please do have a look out at the whole suite of modules available to you, and hopefully you'll be able to find things there that can continue to meet your needs throughout the year between these static webinars. So next slide, please. So from Run 13, we had a staggering over 500 individuals registered to participate. But as usual, we do see a drop-off of individuals who actually do complete the full assessment module. So we had 317 submitting classifications for Run 13. And quite amazingly, this is coming from individuals based in over 44 different countries. So see along the top graph here, you can see that the majority of participants are based within the UK, but the graph below, if you take out that large number, you can actually say we really do have quite a global spread, which is fantastic. So welcome, everybody. Next slide, please. One of the other advantages of providing these types of modules is we can actually survey those individuals completing the classifications just to find out which guidelines they are currently using. So just for a change here, we can start looking for any shift. And on the left-hand side, the pie chart represents our Run 13 participants, and on the right-hand side is our Run 12. And I would just say the main thing to note here is we can see a shift from the ACMG guidelines only to more of using Enigma guidelines. So that's quite an interesting movement there. Next slide, please. We also can start asking for the background of the individuals and whether or not they are a scientist or medically trained. So here on the left-hand side for this run, you can see that the majority, not surprisingly, of individuals come either from a clinical genetics background or genetics themselves. So that's 28% and 43%. Although we do have a small number of hematologists, but again, predominantly we have 11% from oncology background and 10% from pathology, with another 7% coming from others. As well as finding the clinical discipline, we can also find out the experience and the expertise of the participants. So this is self-declaring expertise. So again, not surprisingly, the majority of individuals, 44%, claim that they're an experienced scientist, which would really confers with the background in genetics. The majority of others are from a quarter of individuals are from an other discipline. So I think what we'll do as a take-home message is maybe start looking at what that other category could be so we can define this a bit more clearly. Next slide, please. So this is a summary of the 6 variants that were included in Run 13. As always, we do like to get a spread of different genes and also the different expected classifications, as well as different types of variants. You can see here we've got one variant that was class 1. We've got 2 that come out as class 5. So we have both extremes of the classification remit, the scope. And we have 2 here that both were variants of uncertain significance. Now, you'll note here that the 6th variant, the RAD51D, has different classifications depending on which guidelines you apply. So we'll have further discussion and background into how that comes about later on in this webinar. Next slide, please. So these are the results coming out from this run, and I can see here that we've got a definite improvement of the number of individuals who are correctly classifying all 6 variants. So we have a percentage of 9% of our participants correctly classifying the 6. You'll see also here on the graph on the left-hand side that the majority of participants classified 4 variants correctly. So I think we can definitely see an improvement with those who are continually participating in these EQAs. So next slide, please. So I'm now going to hand over to Kathleen to get an in-depth summary of variant 1.
Hello, good afternoon. So next slide, please. I will discuss the first variant, which is an in-frame deletion of 3 amino acids within ATM. And the in-frame deletion is located in the functional fatkin domain of the ATM protein. Next, please. So what data are available in all kind of databases for this variant? Well, you can find it back in GNOMAD. It is present in 6 alleles in the GNOMAD version 2.1 non-cancer, and also in the GNOMAD 4.1, there are already reported 101 alleles. In ClinVar, there are some discrepancies, but the majority have reported it as pathogenic or likely pathogenic, and it's once reported as a variant of unknown significance. Also in LOVD, it is present, and also there you see similar distribution as in ClinVar. And then for the in silico predictions, the Provian score was looked up, and you see that there are very negative values pointing towards a deleterious effect. Next one. So here you see the criteria we have applied, and these are the criteria you can apply according to the VSAP guidelines and the CanVIC guidelines, as CanVIC has copied the instructions from the VSAP. So the first criterion we have applied is PVS1, but we have applied it at the supporting level. So normally this is used for loss of function variants. However, it is a bit reinterpreted within the guidelines, because it is you can apply it at PVS1 supporting when an in-frame alteration is present in a functional domain. So here it is a Fatkin domain, and with a Provian score suggesting a pathogenic effect. And you have seen on the previous slide that they were all negative values, so below the value of the cutoff for pathogenicity. We must admit that it's currently not so easy to download the Provian score. So we needed the help for some bioinformatics from that. So and we will discuss later, but that might be a reason why many applicants could not apply this score. Another criterion we have applied is about the functional tests. We have applied it at a moderate level. There are several studies who have shown a detrimental functional impact, and these can easily be looked up in the supplementary tables of the VSAP guidelines, where you can find the results for the kinase assays and the radiosensitivity assays. And then we have also applied PM3, but at a very strong level, because there are several individuals reported in the literature that have an AT phenotype and that were homozygous or compound heterozygous with another pathogenic variant in the ATM gene. And it's written in the guidelines that when there are multiple unrelated cases, you can, this is an additive, and per patient with a confident phenotype, and the confident phenotype is also described in the guidelines, there are 2 points to earn. So there are even more than 4 patients reported in the literature. So we came up to 8 points, making it very strong. So we could classify it as class 5, based with a supporting is 1 point, moderate 2 point, very strong 8 points. So in total, we have obtained 11 points. Next, please. Here you see an overview of the classifications submitted for this variant, and you see that the majority reported it as likely pathogenic or pathogenic. And yeah, I did not see a real relationship between the guidelines used, Enigma, CanVIC, ClinGen. The similar results were obtained, with the majority reporting it as class 4 and not class 5 like we did. So next, please. So how was it performed? So PVS1 supporting was only applied by a small minority of the participants, so 31. PS3 moderate was applied by many more, and also PM3 very strong was applied by many more, although some there was also many participants who applied it only at strong level, and this may also have caused the fact that they came up with a class 4 instead of a class 5. So the applicants that came up with class 3, they failed to apply PVS1 supporting, and they often also failed to apply PM3 very strong. There were some of them who applied it only at moderate, and so they could not reach the level for pathogenic. And the ones that came up with class 4 failed to apply PVS1 supporting. Several have applied PS3 only at the supporting level, while you can use it at the moderate level according to the guidelines. And also PM3 was not applied at high enough level. Next, please. How some applicants use some codes that should not be applied, like PM2 was very popular by some of the participants. So PM2 is you can apply when it's absent from controls. However, according to the VSAP and the CANVIC guidelines, you can use it maximum at supporting level. And while there were even some people who applied it at strong or very strong, and many at moderate. However, the guidelines say that you can only use PM2 if the frequency is smaller than or equals to 0.001%. And if there is only one allele in a single subpopulation. So this, when this is the case, you can use it as PM2 supporting. However, we have seen that in GNOMAD, this variant is present in many more alleles. So, and the guidelines say if it's present in more than one allele in one or multiple subpopulations, it's not sufficiently rare and PM2 supporting cannot be applied. And you see here a print screen from the GNOMAD 2.1 non-cancer subcohort, and you see that there are in total 6 alleles and 5 alleles within the European non-Finnish subpopulation. Next slide, please. Other codes that were applied is the PM4, and it's, according to ACMG 2015, this is indeed a code that you can apply specifically for in-frame deletions or insertions in non-repeat regions. However, the guidelines now say that you should not use it in ATM for in-frame deletions and insertions, as there are no sufficient data available for this rule at this time. PP3 was also applied by some participants. So this is the rule about computational evidence, and you can use you can apply it if the Revel score is more than 0.733, but this is only applicable for missense variants and not for in-frame insertions or deletions. And then PP5 is about a reputable source that can be applied according to ACMG 2015, but in many VSAP guidelines, this is not applicable anymore and should not be used. Next, please. So after the ATM variant, we move to a BRCA1 variant. Next, it's also, next slide, please. It's also, oh no, the previous one. Yeah, it also concerns an in-frame deletion, but not located in a known functional domain. Next, please. What data are available? Also, this variant is present in GNOMAD. Also in the BRCA exchange database, there are several data about it, especially about likelihood ratios, that it may be easier to look up the data there. In ClinVar, there are several submissions that are reporting it as a variant of unknown significance, and also in LOVD, it's considered as a variant of unknown significance by many submitters. Next, please. So here, for BRCA1, there are guidelines formulated by Enigma and also by CANVIC. Although there are different, the criteria that are applied are quite similar, but strengths are a bit different. But altogether, we came up with the same classification for either if we use Enigma, either if we use the CANVIC guidelines. So for Enigma, we can, for both Enigma and CANVIC, we can use the BS3 strong. It's about the well-established functional studies that show no damaging effect on the protein level. And both guidelines refer to the paper of Bowman et al. That was published in 2020. And for the Enigma guidelines, there is a table 9 added as an addendum to the guidelines, where you can look up the strength and outcome of this functional test. Or you can also easily look it up via the BRCA Exchange database. And for the CANVIC guidelines, there are also nice descriptions available about the functional tests that can be applied and at which strength. Then for the BP1 strong, it's only, this is a criterion that is applied by Enigma. So originally it was for missense variant in genes where there are primarily truncated variants known to cause disease. However, it's a bit reinterpreted in the Enigma guidelines. So you can, you see it in figure 1A that is provided as an addendum to the guidelines, where you see when for in-frame variants that are localized in areas without a known functional domain and no splicing predicted, you can use BP1 strong. But to be honest, the splice AI score for this variant is actually a bit higher than 0.1. But in table 9 of the guidelines, it's explicitly mentioned that there is no effect on splicing. So that's why we decided that we could apply BP1 strong. We also applied BP5 at the supporting level. So also this criterion has a bit reinterpreted by in the guidelines towards the fact that we can use likelihood ratios based on segregation data within several families. So the hallmark paper for this is the Parsons et al. From 2019, where you can look up the likelihood ratio is 0.368. So that's between 0.23 and 0.48, which is the range for this for applying BP5 at the supporting level. Also, these values can be looked up via the BRCA Exchange database. So altogether, with all these scores, we came up with -9 points. So this is in the benign range. For CANVIC, the BP1 strong, can not be applied, but the BP5 can be applied at very strong. And this is based on the fact that another paper, a more recent paper than the Parsons paper, it's the one from Caputo et al., which is listed in the CANVIC guidelines, where they show that co-segregation showed a posterior probability of pathogenicity below the cutoff for BP5 very strong. And so because of this, multifactorial assay can be used. According to the guidelines, you can use it at very strong. And altogether, you have -12 points. And this also leads to a benign classification. Next, please. So what we learned from this graph is that many of the participants have classified it as benign or likely benign. However, the majority came up with uncertain clinical significance. And as you can see from the right graph, it's a bit independent of the guidelines used, either Enigma, either CANVIC. You see that with these guidelines applied, many people came up with a variant of uncertain significance. And the reason for this will come, I will show later. Yeah, next, please. So for 46 applicants indicated that they had applied the Enigma guidelines, and many more had applied the CANVIC guidelines. Many have applied the right parameters, but sometimes not at the adequate strengths. So, and this may have led them to, other classifications. Next, please. So, as we saw that more than half of the participants came up with a class 3, we looked up why they came up with these criteria, and this was we had not applied any criterion that pointed towards pathogenicity, but many of the applicants that came up with class 3 have applied some of these codes. So PM2 was again a very popular one, but should not be applied because it's too frequent, both for the Enigma guidelines, where you look at GNOMAT version 2.1, the non-cancer subset, and the GNOMAT version 3.1 non-cancer subset. There it should be completely absent, and there are 4 alleles present. In the CANVIC, according to the CANVIC guidelines, it should be absent from GNOMAT version 4.1. However, it is present in 14 alleles, so should not be applied. Many people also applied the PM4, so it's the one about the in-frame deletions or insertions. According to Enigma, this is not applicable and should be considered as component of the bioinformatic analysis. And CANVIC has actually copied this because they also anticipated that these elements will be all incorporated in the in silico predictions, but not yet in this version. And especially for the ones in key domains, but the amino acid 1298 that is deleted here is not located in any of the functional domains. Next, please. Several people also used PP4 instead of BP5. So PP4 is the, indicating that segregation points towards pathogenicity. And some participants have indicated the likelihood ratio that they had applied. And they had applied the likelihood ratio from the Parsons et al. Paper, but they took the combined likelihood ratio at 28. However, it should be the posterior probability should be applied, and this is 0.368. So when applying the combined likelihood ratio, then you have this value of 28, and then this falls within the PP4 strong range. However, it's not the correct one that was applied. And I can also advise to look up these things via BRCA exchange, because there it's immediately clear that the posterior probability of pathogenicity is 0.368 and something. Next, please. Other codes that were applied and should not be applied is the BP4. So the computational evidence was applied by some of them, by some of the participants. Although the bias del is definitely within the range of non-pathogenic, you cannot apply it because it is, the variant is located outside of a functional domain. And for CANVIC, the protein impact should be evaluated via REVEL, but this is only for missense variants and not for deletions. So this criterion is not applicable. Next, please. And then with this, I would like to hand over the slides to Miranda for variant 3 and 4.
Lovely. Thank you so much, Kathleen. So I'm going to do variant 3 to start with. Next slide, please. So we are sticking with BRCA1 here, and we have got a synonymous change, but it's a bit of a tricky one because it was actually affecting the last nucleotide of exon 11, or that's exon 12 if we're using the legacy numbering. So we know that this may have a putative splice impact. Next slide, please. And then looking at the different databases and resources that we might use for our variant classification, this variant is completely absent from NOMAD version 2 and NOMAD version 3. It is present in NOMAD version 4, but on just one female non-Finnish European allele. It's listed as pathogenic on both BRCA Exchange and ClinVar. And if you look at the in silico predictions, as we thought it may be, you can see that all of these have a really significant short score predicting loss of that donor site and affecting splicing. Next slide, please. So how do we use that evidence in to apply our ACMG codes and the strengths? So if you do any kind of literature searching, whether that's via HGMD or Google Scholar or Mastermind or whatever tool you use, you can see very quickly and easily that there have been these two papers published, one by Kathleen Claes, who we've just been hearing from, and the other one, Wappenschmidt. And both of these did RT-PCR assays on this variant and showed that from the RNA studies that you got skipping of exon 12, which was out of frame. So we have used that under PVS1 strong RNA, and I'll explain that in a bit more detail in a minute. Because of the absence from NOMADS version 2 and version 3, the Enigma guidelines would apply PM2 as supporting. And then, as Kathleen has already said, we also have the Enigma multifactorial data from that fabulous Parsons paper available, and that has a likelihood ratio of 8.6, which means it's equivalent to a PP4 of very strong. So altogether, we get 13 evidence points for this variant, clearly class 5 pathogenic. Next slide, please. Then moving on to the CAMVIG guidelines, the first 3 rows of evidence are exactly the same, but for the RT-PCR, the actual code we've used is slightly different. At the moment within CAMVIG, we are still using the PS3 code, and but we are applying that at the same strength as strong. The PP4 and the PM2 are the same as the Enigma guidelines. But in addition, in the UK, we also collect nationally all our hereditary cancer testing data together, and we submit it to the National Disease Registration Service, and all of that data gets put on the publicly available CAMVAR database, and so we can use that data to do a case control analysis. And that gives us very, very strong evidence, very strong for using PS4 for that case control. So for this variant with that as well, we get a whopping 21 evidence points towards pathogenicity. Next slide, please. So looking at how well participants classified this variant, it's really excellent. Like the very vast majority scored it as pathogenic, only a few as lightly pathogenic, but you would expect the clinical consequences to be the same. And then there was just 2 participants who scored it as likely benign. Again, as Kathleen said, if you look at the different guidelines, there doesn't seem to be anything that's specific to one guideline. So it's very reassuring for those of us that are involved in writing guidelines, because it means there's nothing that's unclear in the guidelines. It's probably just that they're very long and there's lots of them, and that participants are taking a bit longer to kind of get to grips and familiarise themselves with all the information in the guidelines. Next slide, please. So let's have a look first at the RNA evidence. As I said, we've got these 2 different papers showing the skipping of exon 12. Both of them had no specific quantification, but there was no evidence of any leakiness or incomplete splicing. We've applied the RNA evidence based on Enigma guidelines, but which was based on the Walker et al. ClinGen splicing SBI guidelines that came out last year. And if you were present at the previous webinar, I actually did quite an in-depth review of that, and that webinar is now available on YouTube. So I'm going to very, very briefly go over it in the next couple of slides, but if you want more detail, then please have a look at that webinar. Next slide, please. So in the Enigma guidelines, if you've got a variant you think could be affecting the RNA function, you would go to figure 9. Next, please. And the first thing you're going to do is check to see whether your synonymous variant affects splicing. As we know, in this case, it does. Next, please. And then we're going to look to see if there's any functional data that's supporting that in silico prediction. Next, please. And what we're going to do is we're going to have a look at the assay design. Next, please. And then we're going to have a look at what the predicted effect of that variant is. In this case, we know that it's an outer frame skipping of that exon. So we would be expecting to apply PVS1 at its highest strength of PVS1 very strong because of that outer frame subject to NMD. Next, please. But there's a little bit of a caveat with the splicing data because we need to weigh up that kind of predicted strength with the assay design and with your percentage of wild type versus aberrant transcript produced. And Enigma very helpfully have this table 9 so you can see this data. Next, please. And I've just kind of highlighted this wording here that I'm going to come back to in a couple of slides' time. Some new information hot off the press. Next, please. So we're going to have a look now at table 9. Next, please. And the second half of the table shows you the assay results using patient RNA without allele-specific quantitation. Next, please. And as we've already said, we're going to have a look at our PVS1 decision tree. We're going to apply PVS1 at the highest strength. Next, please. But because we don't have any allele-specific quantification, so we really, from kind of one of these slightly older kind of gel-based assays, we really don't have that accurate quantification data to see if there is an incomplete splicing. Enigma downweight that by 1 kind of factor for the very strong to strong, and then you'll see for the other evidence strengths, they're all kept at moderate. So that's why we've applied the strength of PVS1 strong. Next, please. So moving on to the CAMVIG, next, please. So again, and next as well, thank you. So as you can see, we are still applying this evidence under PS3, and generally if we have 2 orthogonal assays, we would apply that at very strong, but we have this additional caveat as we really want these assays to be performed in a diagnostically ISO accredited laboratory rather than a research laboratory. And so therefore, if the publications or the evidence is only from publication, we would downgrade by 1 level of evidence. So we also apply it here at strong level. Next, please. And just to say that we are now very close to releasing the new version of the CAMVIG guidelines, version 3, where we have moved over the RNA evidence from PS3 into PVS1 RNA. So keep an eye out for that for the next run. Next, please. And now I'm just going to very quickly take you through how we did the case control analysis. So if you go to the CAMVAR UK website and go to the case control frequency, next, please. And next again. So you can see on the right-hand side, the number of cases we have seen it in our entire diagnostic population. So roughly 4 out of 60,000. And what we can do is we can do a case control analysis, comparing it to the UK Biobank females as our closest matching control population. Next, please. This allows us to do some very clever maths using Fisher's exact, which I'm not going to go through because all of the details are in the CAMVIG guidelines, but gives us this very strong evidence towards pathogenicity. Next, please. So, as I said, I think everyone did very well at this. So nearly 93% correctly classified this variant as pathogenic. However, when we start kind of looking in a bit more detail and looking down at the codes and which codes were used and at what strength, we can see some discrepancies. So if we look at the use of PVS1, actually more participants applied it at very strong than applied at the recommended strength of strong according to those Enigma guidelines. Looking at PS3 for the CAMVIG guidelines, slightly better here. So the majority applied it as strong at what we'd recommend. But again, you've got quite a high number, 44, applying it at supporting level. So I would just recommend if you are one of the participants that's kind of applied one of those code strengths in red, is that you have another read through the guidelines so that when you are classifying kind of patient data, you are ensuring you're applying it at the right strength. And then the next point is about double counting. So particularly for splicing, we would not count both the in silico and the functional data together. We consider that double counting. And 86 participants applied both PS3 with PP3, so that's the functional and the in silico data, and 40 participants also applied the PVS1 RNA and the PP3. So please remember that the functional data would supersede your predicted data in this case. Next, please. So just 21 participants, 6% classified it as likely pathogenic. And this was generally either because they didn't apply any of the RNA evidence, they generally used just the in silico evidence supporting instead, or they didn't use the Enigma multifactorial evidence. Next, please. And just to give you a reminder in terms of where you can find that multifactorial evidence, if you go to Canva and the genetic epidemiology tab, it's there. And next, please. If you go to the BRCA Exchange website and make sure you're clicked on the detailed view, then as Kathleen's also just shown, you can see the multifactorial data there. So these are both very useful, easy to look up kind of sources for that data. And as you can see, gives a lot of evidence towards pathogenicity or benignity. Next, please. So same as Kathleen said, I think this comes up every run, but we had 39 participants applying PP5 as a reputable source, but this was discontinued in 2018. I know that some people are using these automated classifiers, but if that comes up, then please try and look who's classified it and where that evidence has come from and apply it in the correct codes. We also had 105 participants applying PS4 for case control analysis. For this example, there wasn't a published case control analysis. Therefore, this code is allowed using the CAMVIC guidelines, but not the Enigma guidelines. And again, if we look a deeper dive at what strength was used, then only 17 applied it at what we would recommend using the CAMVIC guidelines and that case control analysis at very strong. The majority used it at that PS4 default strength of strong. And actually over half of the participants that applied PS4 stated that they were using the Enigma guidelines for PS4. Next, please. And this kind of feeds in with the next point, is that lots of them reference the Enigma multifactorial data, and the same with the co-segregation and the use of PP1. So the recommendation is you use the Enigma multifactorial data as a combined score under PP4 only, but some participants were applying it in PS4 as well as PP1, and then not using that PP4 code. Next, please. Same as what Kathleen said, and again comes up in multiple runs, but those very high strengths of PM2. So just to remind you that generally across ClinGen, the strength of this is recommended to be capped at supporting. In the UK, we do have some exceptions, and if it's completely absent from NOMAD and from UK Biobank, we would apply it at moderate. But just to remind you that when the next version of the new ACMG version 4 guidelines comes out, there will be no points at all for rarity in controls. So really, please do try not to overweight this criteria. Next, please. Right, so now I'm going to go back to that little bit I had highlighted in yellow. So when we were classifying this variance, myself, Kathleen and Thomas discussed the use of PS3, because a new thing in the Walker et al. Splicing guidelines is that you can now use the PS1 code for other variants within that same splice region as your kind of variant of interest. However, we interpreted from the Walker et al. Decision tree and from Enigma figure 9, where it says if RNA evidence replaced bioinformatic codes with PVS1 RNA, that we wouldn't apply PS1 in this case. And most of you as participants seem to agree with us, because only 19 of you used those codes together. Next, please. However, I've only in the last couple of weeks been made aware of this new document that's available on the ClinGen Splicing SVI webpage, which is a kind of a dynamic Q&A and response to feedback. Next, please. And if you read through the questions, you can see on question 7B that this exact same question was asked by somebody, and the authors have replied and said that it is okay to apply PS1 as well as PVS1 RNA. Next, please. So I had some email correspondence with Stephen Harrison, who was very good at replying to me very quickly, confirming that we can use these codes together. We have to have the same caveats, that the variants must have the same impact at the same levels. And he also confirmed that we can use this document as an official addendum to the guidelines. So next, please. So as I've said, we didn't use it for this variant and it wouldn't have affected the classification, but we will be incorporating this in future runs. So it's really worth keeping an eye on this document. And I thought it would be a really useful place to highlight this here. So yeah, quite hot off the press. Next, please. Okay, we're now going to move on to variant 4. Next, please. And again, BRCA1, this is a nonsense variant causing a premature truncating codon in exon 9 or exon 10 if you're using the legacy numbering. Next, please. It's completely absent from all versions of NOMAD. It's not been reviewed on BRCA Exchange. It is a VUS on both ClinVar and LOVD, although LOVD also has a couple of benign entries as well. And I know normally you wouldn't do any in silico tools for a nonsense variant, but in this case, if you do look at Splice AI for this, you can see that it's predicting both an acceptor loss and a donor loss of that exon 9. So it's predicting you're going to get full skipping of exon 9/10. Next, please. And so the only code that we applied in this case was PM2. Sorry, there is a slight error. That was my fault, and I didn't get the amendments made in time. But actually, we would use PM2 supporting for the Enigma guidelines, but we would use PM2 moderate for the CANVIG guidelines because it's completely absent in NOMAD 4 as well. So we'll make sure that that is made clear in the final report. It does not affect the classification. It still remains a class 3 variant of uncertain significance. Next, please. So looking at how participants classified it, I'm actually, really impressed that the majority of participants got this as a class 3 variant as expected. There are some that classified it as class 4 and class 5, which would have clinical implications for if this was a real patient and their family. But again, looking at the guidelines, there doesn't seem to be something specific to the guidelines. So I think it's just that familiarity with the guidelines. Next, please. So this is an interesting one. It's a nonsense truncating variant in exon 9, right in the middle of the gene. So why didn't we apply PVS1? Next, please. And this is based on this original paper from Colombo et al. 2014, but it's since been supported by multiple other studies that shows that you get an in-frame BRCA1 isoform that lacks both exons 8 and 9, or 9 and 10, and it's highly expressed in blood in unaffected individuals and normal breast tissue. And so this isoform can actually functionally rescue any loss of function variants within these exons. Next, please. So if you're looking to apply PVS1, the obvious place to do it from is using the Enigma PVS1 decision tree. So here it's shown is figure 3. Next, please. And we've got a nonsense variant where we have a protein truncating codon and we're predicting NMD. Next, please. But the variant is absent from the biologically relevant transcripts. Yeah, we know it's in that exon 9/10, so therefore PVS1 is not applicable in this case. Next, please. Next, please. And next, so the other place that you can go and have a look for this data is table 4 Enigma, which again is a really helpful lookup table for every single exon, and it gives you some notes that you're getting the rescue expected, and again it's telling you that PVS1 is not applicable. Next slide, please. So again, pretty well answered. Over 79% correctly classified it as a VUS. However, if we do a bit of a deeper dive, there were 19 of these participants who still applied PVS1, including 11 at very strong. We know that that code should not be used for this case. Interestingly, 27 participants did look at that splice impact and apply PP3 due to that splice AI score. However, we know that even if it was a full exon skipping, again, that's not going to be functionally relevant, and so we wouldn't apply PP3 either. Next, please. So of the 12% that classified it as pathogenic, the vast majority were due to that use of that PVS1. I think just seeing that it's a truncating variant and then applying PVS1 particularly at very strong. Next, please. And exactly the same really for the lightly pathogenics. About 8% classified it as lightly pathogenic, and nearly all of that was due to that misuse of PVS1. Next, please. Next, please. So again, banging on about the PM2 at the inappropriate strengths, and the use of PP5 was seen, I think, kind of consistently through all these different variants. So overall, I think these were two really tricky variants, but the results were good. But yeah, just remember that things may not always be as they seem, and not all protein truncating variants are pathogenic. So I'm now going to hand over to Thomas.
Thank you, Miranda. So now we will move on to variant 5. Next, please. It's a splicing variant in BRCA2, and it's a +2 T2C change, and it's located in intron 22. Next, please. This variant is absent in NOMAD 2.11. It has not yet been reviewed in the BRCA exchange database, but it has been reported once in ClinVar as likely pathogenic. And there's also one entry in the LOVD database where it's also recognized as pathogenic. And if you look at the in silico prediction, it is predicted by several programs to destroy the donor site, but there is one program, splice site finder-like program, that doesn't show any effect. And also the score from splice AI is rather low, at least with the donor loss. And this is also a trigger variant since it's located on position 2, and it's a T to C change. Next, please. According to the ENIGMA guidelines, we have only applied one criteria, and that's the PM2 supporting, since it's absent in GNOMAD 0.21. We have, according to the CANVIC guidelines, applied 2 criteria. We can apply PM2 moderate because it's absent in GNOMAD 4.1. But in CANVIC, you can also use the PP3 sub criteria, since several tools, computational tools, show that it's disrupting splicing. But anyway, both guidelines classify the variant as a class T3 variant, the ENIGMA with 1 point and the CANVIC with 3 points. Next, please. And the summary of the participants' classifications. You can see that there is a lot that has classified the variant correctly as a class 3, but there is a substantial amount of participants that has classified this variant as a class 4 or class 5 variant. And it looks like it's evenly distributed using different guidelines. Next, please. And the main reason for this for the likely pathogenic or the pathogenic classification is due to the use of PVS1. So PVS1 has been used 87 times, and PVS1 strong has been used 24 times, and also PVS1 moderate has been used. So that's why we see a lot of participants classifying the variant as either class 4 or class 5. Next, please. So I mentioned that this variant is a tricky one, and that is due to the fact that in the human genome, a small fraction, or almost 1% of introns contain a GC as a donor site. And that is the site that this change make. So in the Clinton splicing paper, it is stated that you should be very careful when you have a +2 T2C change, and that you cannot apply any PVS1 evidence. It's not applicable. And the same also goes for ACGS guidelines, which are the newest one from 24, where it's also stated that PVS1 should not be applied for +2 T2C variants, especially if the splice AI data is below 0.8, and there's no RNA evidence. And in this case, we do not have any functional RNA data. Next, please. So when you look at the ENIGMA guidelines, you're also referred to the appendix, and in that part you also refer to figure 6, and you have this BRCA2 PVS1 decision tree, and you can see that this particular variant is actually mentioned, and it is shown that the PVS1 criteria is not applicable, and also the same as stated by the English community, UK community, that the splice AI has to be above 0.8 if you should use any criteria. Next, please. Then a lot of participants has also used PP3, the in silico data, and according to the ENIGMA guidelines, you cannot use PP3 when the variant is located in the acceptor or the donor sites. So it's only for variants outside this domain. And this is a bit different compared to the CanVic, where you can use PP3 if, as I said earlier, if multiple in silico predictors show an effect on splicing. So that was actually the main difference between the ENIGMA and the CanVic guidelines. Next, please. Yeah, regarding the PM2, as already stated, the ENIGMA guidelines only use the PM2 supporting criteria, whereas CanVic also use the moderate. And as the variant is not present in GNOMAD 4.1, you can always also use PM2 moderate in the CanVic guidelines. Next, please. Yes, thanks. And also, as mentioned both by Kathleen and Miranda, a lot of submitters used the PP5 that the variant is reported in databases, and that is not applicable either in the CanVic guidelines or in the ENIGMA guidelines. So that's just a point to keep in mind, as already stated. Next slide, please. Okay, then move on to the variant 6. Next, and that's 4 base pair deletion in the RAD51D gene, and then that is a variant that introduces a frame shift, and it's in the RAD51 domain, and it's in exon 6 of the RAD51D gene. Next slide, please. And this variant is absent in the GNOMAD database 2.11. It is reported twice in the ClinVar database, both as pathogenic, but not in the LOVD database. Next, please. And if we look at the different guidelines that we have used, then if you look at the ACMG guidelines, you can use PVS1 very strong, as it is expected that this variant introduces a loss of function variant that results in nonsense-mediated decay, since the variant is located in the middle of the gene. And also using the ACMG guidelines, you use the PM2 supporting criteria, since it's absent in NOMAD 2.11. So using these criteria, the variant is classified as a class 4 with 9 points. If you use the CANVIC guidelines, you can also use the PVS1 at a very strong level, using the same evidence. It's also a PM2 supporting. It's not reported in the NOMAD database 2.11, and that's the database that is recommended to use at this point. But it is actually found in 5 alleles in the NOMAD 4.1 population. And then using the CANVIC guidelines, you can always also use PM5 supporting. It's a category where you have in previously used it when you find a novel missense variant and detect a different amino acid in the same position that has been determined to be pathogenic. But in this case, you can also use it for truncating variants, and there has also been identified several other truncating variants in this exon. So you can use PM5 supporting here, and it's I guess it's pretty much the same argument that you actually use this PM5 in the BRCA1 and the BRCA2 in classifying variants there. So using this, you actually get 10 points, and therefore the variant is a class 5. Next, please. And this is maybe a variant where most participants got it right. It's both classified as a class 4 and a class 5, and very few has classified it as a class 3. And if you look at the guidelines used, most have used the CANVIC guidelines. Next, please. And just showing the difference in the PM2 criteria between ACMG and the CANVIC guidelines. As already stated, the ACMG, you can only use PM2 supporting, and you, in the CANVIC you can use PM2 moderate, but regarding the RAD51D, it's been decided to follow the ATM guidelines and only use the PM2 supporting criteria. So it's the same criteria using both ACMG and CANVIC. Next, please. The PM5, as I mentioned, you can use it for the CANVIC guidelines since the truncating variant is located in the middle of the gene and not in the final exon or within the last 50 bases of the second last exon. And in the ACMG guidelines, this has not been implemented that you can use it for truncating variants yet, but I guess that's something that will be changed for a lot of the genes involved in hereditary cancers. Next, please. And again, PP5 have been used by a lot of submitters, as previously mentioned, and you cannot use it either using the CANVIC or the ClinGen guidelines. Next slide. I think I'm finished. Yes.
Thank you, Thomas, very much indeed, and all of our speakers, Miranda and Kathleen as well. Some great in-depth detail there. So it's quite nice to see have an overview just to look at the performance and the classification submitted by all of our participants for the run. And here's a really nice way of demonstrating that. So you can see our bubble chart here. So the larger the size of the bubble, the more individuals classified that variant in that way. Those bubbles that are coloured in green are the expected classifications, and we've just heard the evidence of why this had come about. And those in red are other classifications submitted by participants. So I think it's really clear to see that we're starting to get some really good condensing of classifications, particularly if it's a 4 or a 5, or it's a 1 or a 2, and it's not changing across the boundaries whereby really patient management would change. So I think there's definite improvement through the runs for continued participation to show actually that there is a benefit for these types of EQAs. So next slide, please. If we sort of take an overview of all of the activity in 2024, so that's run 12 and 13, you can see here that again we've got that widespread of different classifications covered, and also incorporated 3 variants just to demonstrate how the use of different guidelines can actually change the classification. And the one that's I think the most pertinent is actually the first one in run 12, the BRCA variant, whereby there was a variant of uncertain significance, class 3 using Enigma guidelines, compared to a class 4 likely pathogenic through CANVIG. So there was a change in potential clinical management of that patient. However, you could see the other 2, it was either a 4 or a 5. So again, you would assume that most patients would be managed in a similar way there. As always, you can see that we have registrants over the 500 mark, with over 300 participating in each of the cases, which is fantastic. And really just a huge resource that is now available, as Simon mentioned at the top of the webinar, that these webinars are now accessible through both the EMQN and the GenQA YouTube channels, free of charge, and you'll be able to work your way through them if there's more details that you would like to review in your own time. Next slide, please. So a huge thank you to our team of expert advisors. You've heard from 3 of them today, but we've also had George and Andrew and Marjit. So we are really indebted to their great expertise in this subject and the time that they've taken to prepare the cases and the evidence to share with you today. And also a big thank you to Alice Garrett from the ICR in the UK in London for her webinar 3, whereby we had a lot more in-depth discussion about some of the CANVIG recommendations. And again, that is available on the YouTube channels. So next slide, please. We are now endeavouring to put this information together into an EQA summary report that we hope to be available to you either towards the end of December or early January. We are now working to develop and implement Run 14, just due to participant demand that really there's a need to continue these types of exercises, and we will be providing Run 14 early in spring 2025. So registration isn't currently open yet, but you'll be notified by email when it is open, probably about the month before it goes live. But if you need any information in the meantime, please contact either EMQN or GenQA at our office and information email addresses, or on their websites as well. So next slide, please. So now, as Simon mentioned, and I can see we've got lots of questions coming in on the Q&A, we're going to open up to our live question and answer session. Simon, over to you.
Thanks very much indeed, Sandy. So thank you to all of you who've contributed questions. Do keep them coming in. Could I caveat that when you do submit them, please, so that it helps both myself and Sandy put the questions to the panelists, that you let us know what variant you're actually relating the question to. Just makes our triaging of the data coming in a bit more effective, and we can get those questions to the panelists in an easy to use way. So I think we're going to try and run through them in the order of the variants that were discussed in the webinar itself. And I know behind the scenes some of the panelists have already been answering some of the questions for you anyway. So from the ones that we've got at the moment, we're going to start off with variant 1. Now, Kathleen, I know you've already answered quite a few of the questions, and some of the questions that are coming through are quite detailed, so I don't really want to put so really detailed questions to you. But there are, I think, 2 questions relating to variant 1 that I'd like to ask you. So for variant 1, just get this one first of all. So let's, there's a question about the use of PP4. When applying PP4, do you need to look at the posterior probability and the combined logs ratio when applying PP4?
Yeah, I agree that the formulation in the guidelines is quite complicated. And yeah, what I took out from it and what I also hear from colleagues doing it is that we do not use this, that we use the posterior probability, taking into account the likelihood ratio, the prior probability, etc. But I'm not a statistician, so I'm just looking it up with the values that our peers are using. So I'm not sure how to explain it in a statistically good way, but I will do my best to do it in the report and contact some people who know more about it than me. I'm not sure if Miranda has more insights on this, because in CANVIC it's slightly different, and somebody also pointed towards that in the CANVIC guidelines it's written that the likelihood ratios should be used and maybe not the posterior ones, but I cannot answer it on the top of my head.
Yeah, they are looking at, they are quite detailed, aren't they? So I think it would be best probably to pick these up in the actual scheme report itself. So you've got more of an opportunity to go through the actual detail behind it. Miranda, did you want to add anything to that? I think there was also a question on the Provian score as well, or using the Provian.
Yeah, I've answered. I typed that because
right.
It is not very, unfortunately. It used to be really easy to look up the Provian score, and now you have to do it, I think, via GitHub. Also, I just asked my lovely bioinformatics team and got me the data. So, but if you don't have that resource, then yeah, appreciate that that's not very easy to find. So we should really ask the ATM VSEP if they can make that data a bit more freely available, because it's there for kind of each of the different codons. And in terms of that likelihood ratio, one of the reasons I like using CANVAR is because everything has been converted from that posterior probability into the likelihood ratio points. So it makes it nice and easy. But don't ask me about the maths about doing that. I just know that was validated, and so then I trust the results on that.
Yeah, but in CANVAR you can only look up the missense variant. So this is brain deletion, and that's
Right, fantastic. Thank you, both of you. I really do appreciate how difficult this can be doing it live on at last minute. So let's just go to a more general question, really. I think probably one targeted for you, Miranda, for variant 3. So there's a question here about the use of gel images in the publications, which appear to indicate that there's some leakiness. And without quantification, given these publications only, do you not think it is appropriate to be cautious when applying PS3?
So yeah, good question. In actual fact, people were the opposite. Very few people underscored that data, and they tended to overscore it. But going with so remember that both those publications were from patient RNA studies, so you've got the wild type there. So yes, you can see the normal band, but you'd expect to see that in at least 50%. And according to the Walker et al. And the Enigma guidelines, the only 2 options you've got is apparent near complete splicing or apparent incomplete splicing. And neither publication mentioned anything about incomplete splicing. If you do think it's incomplete, then PVS1 is completely not applicable. So therefore, we considered it to be apparent near complete, because it's really hard to get that quantitation, but that's why it is downgraded slightly, because of that lack of quantification. But I don't know if you are just thinking that there is that wild type band there, but that will just be from that patient's normal second allele.
Fantastic, thank you. There was another question related to that as well, but I think you've just really covered the main point there, actually, which is about exactly, which is exactly what you just said about the interpreting the data from those two patients. Sandi, have you got any questions at all?
I have, yes, thank you, Simon. This one's, I think, Kathleen, this was your one. It's the BRCA deletion variant that was benign. Could you go over why PM4 wasn't applied again? It said something about being incorporated into PP3 if using CanVig, but I can't see anything in the guidelines about that.
Well, the guidelines actually state, both Enigma and CanVig, that we should not apply it. And Enigma argues that it should be considered as a component of the bioinformatic analysis, so it should be covered by BP3 and BP4. And with CanVig is telling with the literature, I'm reading it, what they state in the guidelines. Within forthcoming ACMG guidance, it is anticipated that these elements will be all incorporated within PP3 and only awarded to variants within key domains. So, and as codon 1298, which was affected in this variant, is not located in any of the known functional domains, it was not applicable. So I hope this makes it more clear, but we will make sure that we write it down also in the report.
Great, thank you, Kathleen. That would be really helpful. Thomas, can I come to you about your RAD51 variant, please? So somebody's asked, what is the rationale for PM5 supporting and PVS1? Wouldn't it be viewed as double counting, as both are predicting delirious by loss of function?
Yes, thank you for that question. I think you should regard it as additional data using PM5 supporting, because you're looking at other variants in the same exon being classified as either likely pathogenic or pathogenic. So you use that evidence, and the more likely pathogenic or pathogenic variants you have in an exon, the more you can use the more sure you are, then you can use the PM5 criteria, and that's actually what is done. I think it started out in the BRCA1 and the BRCA2, and where they have met some cutoffs in each exons, and where they have, as far as I remember, stated that you should have at least 10 likely pathogenic or pathogenic variants before you can use that evidence. I'm not sure whether it's 10, whether Kathleen or Miranda must correct me if I'm wrong, but I think that's the rationale between using PM5 supporting, where you look at other variants, and then you use PVS1, which is due to the variant in question.
If I can just come in on that as well, one of the other reasons is it came in kind of around the same time that PM2 was dropped from moderate to supporting, and then we ended up in the situation that there were a lot of clearly truncating variants in biologically relevant transcripts that were getting PVS1 very strong, and then only getting PM2 supporting, and were only reaching likely pathogenic when we know that they are null. So that PM5 was brought in, as in the UK we call it a bit of a fudge, because we've kept with the PM2 moderate, but it was another way of saying that that truncating variants in this exon, or some VSIPs have said before, this VSIP is kind of additional evidence to get you that one more evidence points to get it up to pathogenic, because they really should be being reported as pathogenic. So that was a little bit of the context.
Great, thank you, Miranda. And I can see, Kathleen, just for your information, we were talking about the variant 2, and the individual come back saying thank you, that all makes perfect sense now. So that's good to see.
Yeah.
Great, thanks.
Simon, do you want to pick up some?
Yeah, first of all, I just got feedback, one nice bit of feedback from the participants. So just to say that they really find these webinars very helpful, but maybe having a webinar focused on posterior probabilities and odds of pathogenicity, can't get my words out today, and how to apply it according to Enigma were really helpful. So we are obviously would like your feedback on any other further suggestions for the webinar. So do keep these coming in, but we've made a note of that one. So thank you very much indeed for that question. Okay, I'm just scrolling down. Quite a few on the bands in variant 3. That seems to have generated quite a lot of discussion, actually, which is very interesting.
There's quite a lot about PP4, but I'm not quite sure which variants that covers. So about when recommended papers are contradictory, how to go on. So the most recent one over the older one, or what's the guidance there? And that's not linked to a specific variant. So
in CanVig, we tend to say use the most recent guidance. But I don't think I've ever come across a situation that I can think of where it was actually contradictory. It was there was some slight nuances to the score, so we'd use the more updated one because the model has been updated and generally more evidence added. But I can't think of an example with contradictory.
Yeah, but Miranda, I remember that we had this discussion when preparing these variants because the Caputo paper is more recent than the Parsons paper, and which one to use because it might differ in strength. So, and I don't think we had, we found some, evidence. I know in CanVig you say use the most recent one, and then for the Enigma it's not clear, I think.
Okay, Thomas, I think I've got one for you for the RAD51 variant, which is variant 6. Or don't think Sandi, you covered this with the RAD discussion. Given the predicted nonsense-mediated decay, the protein of the exon should never be translated. Then why could a loss of function of the same exon contribute via PM5 supporting?
I mean, I think it's a bit in the same as before. I mean, you use the evidence for other variants that has been found in that exon. It's nothing really to do with NMD because they all should, in principle, induce NMD. So it's just that you have found another variant in that exon that is classified as likely pathogenic or pathogenic. And that's really the evidence that you use. And the more variants in that exon you have found and classified as likely pathogenic or pathogenic, the more sure you are on the results. And then you can use PM5. So it's nothing to do with the individual variants. They all introduce NMD.
Fantastic. Thanks,
I'm not sure whether that covers the question.
Think, well, it wasn't detailed, so it's sometimes hard to actually pull the real question out of it. But I do have a general question for all of you, really. So do you confirm PM2 is not applicable in cases of a deletion or insertion at a list certainly a list in BRCA genes? So why is BRCA exchange sometimes states PM2 is met in these cases? So it's a little bit unclear, but it's about the use of PM2 is not applicable in cases of deletion and insertion. Was that clear enough to be able to ask the question?
I'm not sure how to answer it correctly, but I'd maybe want to make a general remark that in several VSEP guidelines and also in the CanVig guidelines, there have been defined particular cutoffs when you can apply PM2 or not, and this is gene dependent. So it's not that there is one simple cutoff, but it can differ gene by gene. So this is maybe something taken into account and that you have to look up every time. Well, at least me, because I cannot remember the cutoffs by heart.
Yeah, I mean, I think what it echoes, isn't it, Kathleen, is that it's complicated, and you really do need to understand the gene you're actually looking at to realise which guidelines to apply.
I'm wondering whether was it to do with deletion, as in a whole exon, like a copy number deletion?
There has been just come in a clarification where that's a small deletion is intronic.
Again, it's to do with coverage. Then.
Yeah, exactly. You have to be sure that it's correct.
Yeah. And then for CMV guidelines, that there is the NOMAD version 4 structural variants, and if it's 3 or more contiguous exons, there's NOMAD version 4.1 CMV data sets. So you would look in those for copy number variants. We didn't include, we were nice to include one of those this time.
Great, thank you. Sandi, over to you.
Yeah, I'm just looking, see, I think a lot of things we've covered,
haven't we? Yeah.
I think there's recurring themes. One here about variant 1, Kathleen, we missed out. I don't find in the ClinGen guidelines the possibility to use PVS1 supporting to single codon deletion. Where can I find it?
It's specific for the specific variant was variant 1 or
1, yes.
1. So it's the ATM guideline. Yeah, well, there is a PDF document that can be downloaded really at the bottom of the guidelines. It's the ClinGen HBOP ECMG specifications. And when you that document, it's a PDF. There is a nice description when you can use PVS1 at the supporting level, but it's really you have to scroll a bit down so to find it where it's explained nicely when you can use it at supporting level. And it's literally the sentence that I've put on the slides.
Brilliant. Thank you, Kathleen. And we can also put that back in the scheme report as well.
Indeed. Yeah.
That's great. Thank you very much. Okay. Here's one about that's just come in. So I find it's sometimes difficult to extract from the different gene-specific guidelines from ClinGen to know which NOMAD version to use for frequencies, like version 2.1, version 3.1 for BRCA1 and 2. But the other genes, any advice there? Miranda?
I was just going to say, I'll put it in the chat, but I use the CSpec website all the time, which has got all the ClinGen specifications for every single gene across all the different rare disease VSIPs. And so it, as Kathleen was saying, it kind of gives a summary, and really to get some of that finer detail, you do need to go right to the bottom and download the PDF, but often it has things like that, the NOMAD version for that code in there. And so it's a kind of a quick look up.
Brilliant.
I'll find it and put it in the chat.
Yeah, super. And we'll pop it in the EQA summary report as well.
Yeah.
Super. Thank you. Okay, Simon, I think we've covered most things. The themes are running through the rest of the questions that I think we've covered.
Yeah, I agree, Sandi. I mean, I think firstly, it's really encouraging. You've asked so many questions, which is fantastic. And the detail tells us you're really interested in and want to know the exact reasons why we've classified the variants in a particular way. So as Sandi said, we will make sure that we incorporate all of the questions that we haven't managed to get around to in this discussion in the summary report. So you've got a full detail of analysis of it. And obviously, if you have any specific questions that you want to follow up at all, then please do contact the GenQA and EMQN offices, and I'm sure we'll be able to put you through your email through to the experts if we can't answer it if we haven't answered it, should I say, in the scheme report. Sandi, shall we draw a conclusion to it there? I think there's from the list of I think so.
What a fantastic 2 runs of EQA, and I think just huge thank you to all of the teams, both internally in our groups, but also for our experts, but also our participants, because we learn a lot from you as well through all these questions and the feedback we receive. So a huge thank you really from all of us. Yeah,
totally agree with you there, Sandi. And I suppose today we really need to thank our experts for all the hard work they put into it. The huge amount of work goes into running these EQAs. And as you can see from the discussion today, there's a lot of work gone into this 6 variants in this run here. So thank you, experts, very much for your hard work. I'd also like to thank the team behind it for AZ. For all their hard work in supporting and facilitating an MSD. And I'd like to thank my co-chair for chairing, fantastic as always. And finally to thank you guys for for dialing in, for contributing to the EQA. Please do register for the next run, which will be advertised early in the new year. and we'll really look forward to having you join us on the next webinar sometime in the spring. So have a good rest of the day, and we'll be in touch. Thank you.
Bye-bye.
Thank you.